The purpose of some electrical objects is to convert electrical energy into another kind of energy, like heaters and stoves and blow dryers, so we can calculate that. In this example, we have a heater with a resistance of 15 ohms. We talk about the resistance because that's typically how they make this conversion. They have an increased resistance, which causes the electrical energy to be wasted or turned into usually thermal energy. And it's plugged into an outlet delivering 120 volts. What thermal energy is supplied by the heater in 25 seconds? Now I've given you two different equations for electrical energy. Equals power times time, and energy equals current squared times resistance times time. And for every one of these, you could use either equation. And for this one example, I'm going to show you both. So first, we can use this power times time. In order to use that, we have to use the resistance. In order to do that, we have to use Ohm's law. In order to solve for current, and so to solve for current, we do V divided by R, and we get 8 amps. And now if we want to use this one, we say P equals I times V. So in order to solve for P, we do I, 8, times 120. And our power is 960 watts. So now we can solve for energy, doing power times time. Because remember, a watt is a joules per second. So this gives us joules. You can also think about this in terms of the equation we did previously, where power equals work over time. So we're really solving for work. But remember, according to the work energy theorem, the change in energy is equal to the work done. So all of these are interconnected. And when we round to the correct number of significant figures, we get that the thermal energy supplied is 24,000 joules. And that's using the first equation. Now we could use the second equation and get the exact same way, and I'm going to walk through it just this one time so you can see that either way is valid. Usually one is shorter. One will take less time, but it doesn't matter. So if you look at my work and it doesn't match your work, as long as you have the same answer, it's okay. So if we use that second equation, and I'll rewrite it down here, E equals I squared RT. So we had to solve for I here, so we can use that again. Squared times R, which we were given in the problem is 15, times time. And we'll get the energy is 24,000 joules. So it doesn't matter which way you do it. If you see that this second equation was quicker because all you had to do was solve for current, whereas in the first equation you also had to solve for power afterwards. But again, it's a personal choice. Use whichever one you're more comfortable with. Whichever one you see first as being a way to answer the problem is probably fine. Try the practice problems below, and please let me know if you have questions.